In the given circuit diagram, a silicon transistor is used. If I1 equals 10 IB, VCE equals 2 volt, IE equals 1 milliampere, find I1, IB, RE and RC. Alright, now I hope you have tried this question. If you could get to the answers, yes, perfect. Let's get into the question now. Right. Initially, we need couple of equations. So initially, they have given us, they have asked us to find I1, and for this actually we need to apply V equals IR equation. And one thing we should know, I equals IC plus IB. We should know this. And yes, VBE for silicon transistor is 0.7 volt. Yes, these are the things we need to solve this question. Right. Let's get into the question now. So let's try to find I1. So what we can do is we can apply V equals IR for this circuit part. For this part, let's apply V equals IR. So here the potential is 12 volt. You can see same potential. So 12 equals the I1 current goes down. So yes, I1 that into total resistance is 12 kilo ohms. You can see it. So 12 divided by 12, that's 1. Divided by kilo ohms, that's 1 milliamperes. I1 equals 1 milliamperes. Right, we have one answer. Then they are asking us to find IB. Yes, in the questions you can see they are telling I1 equals 10 IB. So I1 we have found is 1 milliampere. So 1 milliampere divided by 10, you get 0.1 milliampere. That's IB. Right. Then yes, RE we can find. To find RE, we need to know the IE current. Right. It's given IE is 1 milliampere. Right. Now to find RE, we need to apply V equals IR for this resistor. Right. To apply V equals IR, we need the potential at E or VE. Right. How do you find VE? To find VE, what we need? We need the potential at this point. Right. If we could find the potential at this point, yes, then we can find the potential at E. So let's find the potential at this point. Right. To find potential at VB, we have a couple of methods. So let's apply potential divider method anyway. So the ratio is 9, 3. So 9 is to 3, 3 is to 1. So I get the fractional value 3 divided by 4, 1 divided by 4. That into, yes, total potential 12. So 3 volt. So around this, yes, total potential is 3 volt. Right. So then there's potential here is 0. So then we can take the potential at this point as, yeah, 3 volt, right? So that means VB equals 3 volt. Then this is a silicon transistor, VB is 0.7, so difference is 0.7. So I can take VE as 3 minus 0.7, that's 2.3 volt. So here we have the answer, VE as 2.3. And now we can find RE. So what we have to do is we are applying V equals IR for this resistor. We know it's 2.3 volt. I it's given 1 milliampere, that 1 into 10 to the power minus 3, that into RE. 0.3 volt divided by 1 into 10 to the. From this calculation we are getting RE equals 2.3 kilo ohms. Right now we need to find RC and IC. To find RC, we need the potential at point C. They have given us VCE as 2 volt, right? So now in that we know potential at E point, VE is 2.3. So VCE difference they are telling it's 2 volt. So VC is higher than VE. Then we can conclude 2.3 plus 2 volt. So 4.3 potential at point C voltage. So it's 4.3. Right now we know the potential difference across RC resistor. It's 12 minus 4.3, 0.7, 7.7, right, 7.7 volt, right. Then we know IE equals IC plus IB. So here I know I equals 1 milliampere and IC plus IB is 0.1 milliampere. So you get IC equals, yes, 0.9 milliamperes, right. So now what we have to do is we have to apply V equals IR for this RC resistor. So potential difference we have found as, yes, 7.7 volt and IC is 0.9 milliamperes and RC. It's a bit hard to anyway simplify. So RC divided by 7.7 divided by 0.9. So let's do the calculation. 77 divided by 9. For 77 we have 9, 8, 72. So 50 we have 9. Yes, 5. 8.5 RC, so milliamperes, that means this is kilo ohms. So we get RC equals 8.5 kilo ohms. So we have all the values. Now I1 we found 1 milliampere, then IB, yes, 0.1 milliampere, then RE 2.3 kilo ohms, then RC 8.5 kilo ohms, right. We have all the values now. If you could do this question, perfect, you have done it, you know the theories. And if you couldn't do the question, yes, go through with these questions again and again, you will finally get there. And if you think this question is valuable, yes, you can share it with your friends, study together and win together.